Hi, I'm Eugenie Brichkov. Today I will show and explain you multimedia capabilities of GR8NET, which is very helpful for your game and application development. Let's look at the sample application first.
Do you want to play with me? Do you want to play with me? Do you want to play with me?
Now let's look at how it works and why it works. Application is a basic program, the slowest but easiest way to implement applications. Continuity and quality of the sound is provided by the PCM playback function of GR8NET, and buffer playback is performed without CPU involvement. Timing is provided by the controlled interrupt generator, and sample addressing and data prefetch is performed by prefetch function of GR8NET. GR8NET is having 1 MB of the RAM and may hold a number of audio samples and pictures. Applications may digitally mix samples before playback. At the beginning of its execution, program loads raw WAV file into the GR8NET RAM buffer. Size of the file is about 56 kilobytes. Then program sets up addressing for wave playback, requiring engine to pre-buffer 5000 bytes as a first chunk of audio data. Next, it prints first word and starts playback of pre-buffered audio data. First argument is bit size of the sample, in this case 16 bits. Second is frequency in Hertz. Next argument is equal to 1, and it causes command to wait until previous 5000 bytes are finished playing through PCM function. Extends buffer by number of bytes indicated in variable a, and exit because a is less than PCM buffer size and buffering is fully performed. As soon as command exits, PCM continues playing audio data buffered in its RAM. And while this data is being played, basic interpreter has some spare time to do other tasks, in this case display next word. This time can be used for anything, for example for changing shape on the mouth on the graphical screen. The point is that CPU should finish such background operations before PCM play depletes, and run another play command with third argument being 1, so that command be blocking until previous PCM data depletes. And these operations are done in loop, varying size of audio data chunk, thus choosing the right moment when CPU needs to perform background tasks. After it reaches end of wait data having last data chunk buffered, it waits for PCM function completing playing last chunk, and then resets playback engine. As you can see, playback is very easy, but of course it is having several constraints. Buffering of data takes time and depends on size of the data. Sample rate and sample size define the time PCM buffer depletes, and thus when CPU have to return to wave data buffering function. At the same time, implementation is very flexible. And most inputs like sample size, sample rate, and tasks to be performed are controllable by the programmer at the stage of application development. Thank you very much for watching the video. I'm sure what I do brings value and quality to your life as programmers and as users of multimedia applications. See you!